Find the solution of the given initial value problem. We have a second order constant coefficient homogeneous linear equation. So we first find the solution of this differential equation, which will have two constants, unknown constants C1 and C2, or you can say A, B, and you find those constants, the values of those constants, using these initial conditions. Okay, so first let's solve this. For we find the characteristic equation. So characteristic equation is 1r squared minus 4r plus 4 equals 0. Let's solve for r. Looks like these factors r minus 2. That means r minus 2 quantity square equals 0, and that implies r is 2. This is 2 with multiplicity of 2, so repeated roots. Okay, and when we have a characteristic equation with two equal roots, r1 r2 equal, in this case 2, then the solutions are ert comma tert. Then we can write down the solution now. Yt is c1 e raised to 2t plus c2 t times e raised to 2t. Now we need to determine the values of c1 and c2 using these two initial conditions, and we come back here to write down the final solution. And notice the second initial condition requires us to find the derivative. So let's find the derivative of this. Y prime is derivative of e2 raised to 2t is 2 times this, so 2c1 e raised to 2t plus c2 t times, so it's a product, so we need to use the product rule to find the derivative. So c2 stays outside. Derivative of first factor 1 times e2t, and leave t alone, and find the derivative of e2t. That's 2. I'm writing in the front e raised to 2t. Okay, this is, by the way, this is t. Now let's use the first initial condition using y at -1 equals 2. That means y value is 2 when t is -1. So we need to use the first here. So y is 2 when t is -1. So this is c1 e raised to 2 times -1, so e raised to -2. So e raised to -2 is a number. Okay, this is an irrational number, but still a number, plus c2 t is now -1 e raised to -2. Okay, which is same as, let me rewrite this, this is same as c1, you can put on the bottom to make it positive, but I want to leave here, e raised to -2 minus c2 times e raised to -2. Okay, that's from the first initial condition. Let's use the second initial condition here. Okay, so using, let me write this because we need to solve this one, and we get another equation here, and we have to solve this system for c1 and c2 using y prime at -1 equals 1. So y prime is 1 when t is -1, so y prime is 1. So 2c1 e raised to 2 times -1, -2, plus c2 1 times this is itself, so e raised to -2 plus 2 times t is -1, e raised to -2. Let's simplify this, which is same as 1 equals 2c1 e raised to -2, and inside plus c2 times e raised to -2 minus 2 copies of e raised to -2. These are like terms now. -2 copies is plus 1, so that's -1, negative e raised to -2. So let me rewrite this one more time. So 1 equals 2c1 e raised to negative 2 minus c2 e raised to negative 2. Now we need to solve this system of linear equations for c1 and c2. Okay, solve for c1 and c2. Okay, if you look at carefully, this second term here and this, they are same. So let's multiply this equation by -1, or you can multiply first by -1. I'm trying to use the method of elimination. I'm trying to eliminate c2 because they are same. So multiply second equation by -1 and this becomes positive, and when we add star and double star, they cancel. Okay, so multiply this by -1 and add with the star, then we have this becomes, when we multiply by -1, let me rewrite, this is same as -1 equals -2c1 e raised to -2 positive plus c2 e raised to -2. Now we're going to add these two. Okay, not the first one with the modified one. When we add, we get 2 plus -1 is just 1, these two 0, c1 e to the -2 minus 2c1, so positive 1c1 minus 2c1, so minus 1c1 minus c1 e raised to -2. That implies divide both sides by -1 here, by the way, nothing means -1 e to the -2. We get c1 equals 1 over -1 e to the -2, which is same as negative in the front. Move this to the top to get rid of this negative exponent e squared. So c1 is -e squared. It's a number anyways. Now we plug this c1 value into the first or in the second, doesn't matter. Let's plug into the first to find c2. Okay, then by star we get 2 equals c1, we just found that to be -e squared times e to the -2 minus c2 e to the -2. E squared times, this is by the 1 over e squared, or if we combine same base, 2 minus 2 is 0, so this is basically 1. So 2 equals -1 minus c2 e to the -2, or move 1 over, 2 plus 1 3, so 3 equals -c2 e to the -2, divide by -e to the -2 to find c2. Okay, so c2 equals 3 over -e to the -2, negative to the front, move this to the top, so 3 already on the top, 3e squared. Now we have c1 here and c2 here. Okay, c1 c2, we go back up and plug in here to find the final solution. Okay, so thus the final answer is now y is c1, and we just found c1 to be -e squared times what is the solution here, e to the 2t, e to the 2t plus c2, and c2 is -3e squared, so 3e squared c2 times t e to the 2t. If you like, you can combine, or you may leave here. If you combine, then -e 2 plus 2t, just 2 plus 2t, just add, because these are two different, you cannot combine these two, minus 3t e square e 2t is e raised to 2 plus 2t. You may leave here, or the best you can do is factor e raised to 2 plus 2t out, that leaves -1 minus 3t final.